In this video, we'll go over about 10 SAT questions that we covered in Chapter 5. They tell us that this angle is 60 degrees, which means this one is 30. So we're looking at a 30, 60, 90 triangle. The side across from 30 is 4. So if we consider this table for the ratios between different sides across from these angles in a 30, 60, 90 triangle, across from 30, x is equal to 4. We want to know what is across from 90, since that's side AB. So we're just going to double it, and the answer is 8. Inscribed in a circle means it fits inside a circle and touches the edges like this. So if we consider our radius, that's going to be right here, 6 root 2, and right here, 6 root 2. So this actually is going to make an isosceles triangle because we have two legs that are the same. To find this side length of the square, we're going to take 6 root 2 and multiply by root 2. So this becomes 6 times 2, or just 12. To find the perimeter of that square, we multiply that by 4. And our answer is going to be 48. So first we use 30, 60, 90 here on the right. They give us that across from 90 is 12, so 2x is equal to 12. And we can figure out which one is across from 60 then, because that's just going to be 6 root 3. That's this height here. Then this other triangle is going to be a 30, 60, 90, like so. And they want to know the length of AD, which is across from 30. So if I know what is across from 60, I know that this is just going to be 6. So the answer is B. So we have several 30, 60, 90 triangles in this diagram. If we start with this one in the middle, we know that this side across from 30, the length is 5, which means the side across from 90, the length is 10. And this one over here is going to be 5 root 3. Let's deal with this triangle next. We know that across from 90 is 10, so across from 30 is going to be 5. And across from the 60 will be 5 root 3. Let's deal with this triangle third. We know that across from 90 is 5 root 3, so across from 30 is half of that. 5 root 3 divided by 2. And across from 60, we're going to take that previous value and multiply it by root 3. This ends up giving us 7.5. At this point, if we multiply 7.5 times 5 root 3, that's x times y, we get 64.95. The answer is D. So if a is equal to 5 root 2, to double that, we get 10 root 2. And in the same way that before, we could take the square root of something like 200, and we could split this into the square root of 100 times 2, or the square root of 100 times the square root of 2, and get an actual value like 10 root 2. That's what we've been practicing in this chapter. We can do the same thing in reverse. We can stick the 10 back underneath the radical, and this becomes 100 times 2, or the square root of 200. So if I set that equal to the square root of 2x, then suddenly 200 is equal to 2x, or 100 is equal to x, my final answer. So we can simplify things here, and this is just 3 and this is just 8. So the square root of x is equal to 5, which means we have to plug in a number to make this true, and that is 25. Since we're taking the square root of 9x squared, we can split this and take the square root of 9 and take the square root of x squared. This is just 3, this is just x. The answer is A. Number 14, let's evaluate with both of these possible values, 1 and 9. On the left, the square root of 4 times 1 is just 2. And on the right, this is negative 2, so that does not work. The square root of 36 is 6, and that is equal to 6. So 9 works. That's going to be number 2 only, B. First, we get the radical all by itself, so we subtract 4 from both sides, and we get the square root of x is equal to 8. Then, to get rid of the radical, we're going to square both sides. So it turns out that x is equal to 64. So we could plug in different values here. If we plug in the square root of negative 4 squared, is that equal to negative 4? So the square root of 16 is equal to 4, which is not equal to negative 4, so I think that's going to be our best bet. If we did plug in B, C, and D, all of those are true, so number 4, the answer is A.